Right now, your heart is actively pumping between 1.2 and 1.5 gallons of blood through miles of biological tubing. To the naked eye, this appears as a simple, uniform red liquid. This solid wall of color is actually the result of trillions of microscopic components packed so densely that they mask the complexity underneath. Medical scientists categorize this substance as a specialized connective tissue, a liquid organ that happens to exist in a fluid state. Unlike the heart or the lungs, which are fixed in a solid, stationary form, this organ is mobile. It provides a flowing environment where billions of cellular inhabitants constantly migrate and interact. It is a delicate mixture composed of a liquid base, colloids, crystalloids, and 3 distinct populations of specialized cells. Reframing blood as an organ highlights its active role. It functions as a mobile workforce, carrying out specific and highly organized physiological tasks throughout the entire body. To see that workforce in detail, we have to unmix the liquid. We do this using a clinical centrifuge, spinning blood at massive speeds. This process relies on a principle called specific gravity, or relative density. The spin forces the heavier cellular elements to the bottom, while the lighter liquid components rise to the top. This is a standard protocol in blood banking. Applying a heavy spin to whole blood lets hospitals physically isolate its parts. The force of the centrifuge breaks it down into distinct layers: packed red blood cells, a buffy coat, and plasma. This physical separation reveals the hidden anatomy of the tissue, providing a clear map of how its daily labor is divided. This breakdown shows the top layer, a yellowish fluid called plasma, accounts for roughly 55% of total volume. It acts as the body's primary transport river, carrying vital suspended proteins and nutrients. Directly beneath it is an extremely thin band called the buffy coat, where white blood cells reside. These cells function as an autonomous security force. They move through the plasma river to identify and neutralize invading pathogens. The buffy coat also contains platelets, the body's emergency repair crew that seals vessel damage. Finally, at the very bottom, we find the heaviest layer, the packed red blood cells, making up about 45%. This creates a symphony of functions, where every distinct element operates simultaneously within the exact same physical space. The plasma is regulating temperature and moving nutrients, while the white cells are actively scanning for infection. At that same moment, red cells are offloading oxygen, and platelets are monitoring for leaks, all happening within a single drop. The true capability of this tissue isn't found in a single component, but in how they coordinate as a unified, multitasking system. To understand how this works, we have to look closer at the heaviest layer, the red blood cell, and its specialized structure as an oxygen transport vehicle. We will explore the mechanics of that microscopic cargo ship in our next episode. Subscribe and hit the notification bell to see how it moves oxygen through your system.